we just saw that when we simplify the square root of x squared, we get the absolute value of x because it's got to be positive. So let's verify that by graphing here. So this is a website called desmos.com, and this is their graphing calculator. A very useful site. You may want to bookmark. We'll use this a whole lot during this course. So if we go graph here, you could also graph this on a TI-84 graphing calculator, but it's pretty handy here. Online, I should say. So anyways, this is the square root of x squared. So that's the equation y equals the square root of x squared. Well, according to what we just found, we should be able to take the absolute value of x and get the same thing. And there it is. Now notice if I take the blue line off, let me make this a little larger here. Should be able to. Oh, it doesn't want to let me there. Okay, that's all right. So if we turn this blue, so if we turn this blue on off, there's the square root of x squared, and the blue one there is the absolute value of x. Notice they're the same, all right? So that just kind of proves that, yes, the square root of x squared is the absolute value of x. So what that means is the square root of negative 3 squared, these kind of cancel each other out, and it leaves us with, is it negative 3? No, it's the absolute value of negative 3. And we know the absolute value of negative 3 is 3. Here, the square root of x minus 3 squared, those kind of cancel each other out. And we have x minus 3, but it's not just x minus 3 because we need to make sure that's positive. So we got to put absolute value signs around that. Okay, so when we have a variable in here, we'll have to put the absolute value because I don't know what x is. And so whatever x is, I could figure out the square root of that squared by throwing absolute values around it. Okay, now, what if we have the square root of 36x to the 8th? Well, what's going to go on here is we need to rewrite this a little bit here. And let's notice what's going on here, okay? So up top here, we kind of have like, I'm going to put a big blue blob there. We've got the square root of big blue blob squared. And what happened? Well, the square root canceled with the square, and we end up with the absolute value of the big blue blob. Okay? In other words, we'll take that. So we want to write this as the square root of something squared. Okay? So the question is, how can we change this into something squared? Well, what number can we square root the 30? Can we square to make 36? Well, that's pretty easy. That's 6. 6 squared is 36. We can rewrite 36 as 6 squared. Well, what about this x to the 8th? All right, we got to explore a little bit here. So let's remind ourselves what x to the 4th means. That means x times x times x times x, right? Okay, so that's what x to the 4th means. So if I have another x to the 4th, well, that means I have another x times x times x times x. Okay. Now if I multiply those, I have a whole bunch of x's multiplied together. And all those x's multiplied together make x to the 8th. So x to the 4th times x to the 4th has to be equal to x to the 8th. Well, another way to write this, well, before I go any farther, notice this. What did we do to the exponents there? When we're multiplying, we add the exponents. That's a power rule that we're going to use quite a bit. X to the m times x to the n is the same as x to the m plus n. Okay, that's a multiplication rule. We'll talk more about it later, but let's just note that right now. Now, notice another way to write this. Since we have x to the 4th times x to the 4th, that's really just saying we're taking x to the 4th and we're squaring it, right? Because squaring means multiply something by itself. So this is just x to the 4th squared. Well, we just said this whole thing is worth x to the 8th. So notice x to the 4th squared is x to the 8th. Those two things are the same thing, just written differently. And here, this shows us another power rule. If we have a power to another power, notice those multiplied make 8. And that's because of our power rule that says x to the m to the nth power is x to the, x to the m times n. That's a power rule. That's another rule we'll be using more as time goes on. Okay. So the key here is we just showed that x to the 4th squared is the same as x to the 8th. Okay, so 6x to the 4th squared is going to be the same as this. So we've written it the same way, and this is something we spend a lot of time in algebra on, and this is where algebra gets its power, because we can take something that we don't know how to do, and we can change it a little bit and change it a little bit and get something that's a whole lot easier to work with. Now, just like up above here with this x minus 3 squared, now that we have this written as a square root of something squared, those little guys are going to cancel each other out. And that leaves us with 6x to the 4th. Now the question is, do we need absolute values around this? Well, we actually don't need absolute values. And here's why. 6 is a positive number. It always is. It's not going to change. It's positive. Okay? And what about x to the 4th? Well, x to the 4th, no matter what x is, if x is a negative number, then we have negative 1 times negative 1 times negative 1 times negative 1. That's negative 1 to the 4th power. Well, these are going to be 1, and these are going to be, these are going to be 1, and 1 times 1 is just positive 1. Every two negatives are going to multiply to make a positive. All right, in fact, if we have negative 1 to the 3rd power, that's going to be negative 1. If we have negative 1 to the 2nd power, that's going to be positive 1. Notice every time we have an even power, we'll end up with a positive answer. So, if we end up with an even power, we don't need square roots. We don't need absolute values. Okay? We don't need absolute value because it's even. Even power means no absolute values needed. All right? Cool. Well, now we're going to be doing a lot of simplifying here. And so when we simplify these things, we want to be able to recognize numbers that are perfect powers. So we're going to start by looking at square numbers, all right? So we want to be able to recognize these numbers. So if we have, here we have a little table we're going to make. Here's the numbers n. We'll call 1, 2, 3, 4. Those are n. So if n is 1, then 1 squared is 1, right? 1 times 1. If n is 2, then 2 squared is 4. If n is 3, then 3 squared is 9. 4 squared is 16. 5 times 5, or 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared, 100. 121 for 11. 144, 12 times 12. 13 times 13 is 169. So these numbers, 1, 4, 9, 16, 25, 36, 49, 64, so on and so forth, are numbers you want to recognize as perfect squares. So we call these perfect squares or square numbers. All right? Well, what about to the 3rd power? Well, if we take 1 and we cube it, 1 times 1 times 1, we get 1. 2 to the 3rd power, 2 times 2 times 2 is 8. 3 to the 3rd power, 27. 4 to the 3rd power is 64. 5 to the 3rd power, that's 25 times 5, 125. 6 to the 3rd power, 6 times 6 times 6 is 216. So you want to recognize these, especially like up to 64 at least. You want to recognize that those are perfect 3rd powers, or we have a name for this. We call these perfect cubes. So cubes for 3rd power and squares are 2nd power, okay? All All right. If we go fourth powers, now these won't show up quite as much, so we don't need to stress too much about them. 1 to the fourth power, 1 times 1 times 1 times 1 is 1. 2 to the fourth power is 16. 3 to the fourth power is 81. That's just 27 times 3. 4 times 4 times 4 times 4 is going to be 256. And 625 is 5 to the fourth power. Okay? So again, you definitely want to recognize at least these first few are fourth powers, all right? And last but not least, fifth powers. We got 1 to the fifth power is 1. 2 to the fifth power is going to be 32. And 3 to the fifth power is going to be 243. All right. So definitely you want to memorize these squares for sure. And these cubes. We're going to use those a lot. Squares and cubes. These other ones we're not going to use a lot. Just kind of nice to be familiar with them. So we'll stop there on this little video, and then we'll continue on the next video on cube roots.